Hello, my name is Nicolás de Penna. I go by Nichete, and this is a presentation about advice auctions. These are a new kind of mechanism proposed for decision markets or prediction markets. Let's start with some motivation. So we have a sequence of decisions that we're going to try to make, and we want a single decision over that sequence. So we want basically a classifier over that sequence, and we don't want to be bound by the decisions that this classifier makes. So basically, we want this classifier to provide us with advice. And notice that this advice might try to be persuasive. So it might include reasoning or other forms of information that can help persuade the actual decision maker. The mechanism works as follows. The principal reveals their information and their expected outcome if no advice is received. So this is going to be their reserve price. And they're going to run a second price auction for a linear share of the reward. And they're going and the right to receive advice from the winner. And so before the deadline, the highest bidder of the auction provides the advice. And once the reward is realized, the highest bidder receives their share. So this basic building block of an advice auction, once we notice that the winner of this advice auction also is facing a decision problem, and they might also want some advice, it can be applied recursively. So the highest bidder in the original advice auction carries itself out another advice auction to see if any of the remaining experts can help them provide better advice. So they're giving a linear share of the linear share of the original reward. And the only thing that they have to do is they have to move the timing backwards enough so they have enough time to incorporate the advice that the other experts, if any of them matches their reserve price, gives them. So let's go over an example. So we have two experts, and each one is going to observe an independent coin flip. And the action that our decision maker has to take is to say if the coin flips are the same or if they're different. So this is a classic problem in prediction markets. In this particular example, there's nothing inherent to the decision. It's fully observable. What was the right action? So the reserve price, given that the principal doesn't see either coin flip, is going to be 0.5. That's the randomized value. And for both of the experts, because they know that they're going to be able to run one of these auctions and elicit the information from the other expert, basically their bids are going to be one and randomly assigned to one of them, what the value is, and then they're going to run a second auction that is going to be in fact won by the remaining expert, and this remaining expert reveals their signal, and then the second expert combines the two signals and provides the right advice to the principal. So this is a nice example in the sense that it's a classic from the prediction markets literature where this complementary kind of information fails to be aggregated. So one thing that is worth noting here is that the advice that we're giving is a message. So this can be a way of agents to reveal their types in a standard game theoretic setting. In a more practical setting, one might think that they might read. So, for example, they might reveal like the entire classifier, or they might reveal not only the classifications that their classifier makes, but also some understanding of why or the composition of how they went about doing it. And the advantages of this mechanism is that it's quite simple. So the basic advice auction, we're currently with a collaborator in the process of implementing it. It's about 100 lines of solidity. And we're also looking for environments where this might be able to test this out. So the example that we gave in terms of the advice for the ICU is something where there is a public data set in mimic free, and we have cleaned this data set and it's public, and if people want to. And we're trying at the moment to allow for the application for the triage nurse to receive the actual advice. So I don't know if in the first version we'll be able to already run the decision market for what is predicted, but maybe for the second run it will be. And I'm very keen to hear either problems with the mechanism that people find or potential areas of application. Thank you.